Welcome to Glencoe Geometry, Chapter 5-6, Part 2. This is Prove Relationships in Two Triangles. So, first let's review what we learned in 5-6, Part 1. And we learned the hinge theorem and the converse of the hinge theorem. It says if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. So what that means is AB is congruent to FG, AC is congruent to FH, and the measure of angle A is greater than the measure of angle F, then BC is greater than HC. Now the converse reads, if two sides of a triangle are congruent to two sides of another triangle, and the third side in the first is longer than the third side in the second triangle, then the included angle measure of the first triangle is greater than the included angle measure of the second triangle. So JL is congruent to PR, KL is congruent to QR, and JK is less than PQ. That means that the measure of angle R is greater than the measure of angle L. Okay, so that's just a quick review. And now we're going to talk about adding this into some proofs. So example 4 on page 374, we're given that AB is congruent to AD, and we need to prove that ED is greater than EB. AB is congruent to AD. Okay, we wrote that's from our given. And I want us to prove that ED is greater than EB. So let's start. So I got our first statement in here, and the reason for that is our given. And then let's talk about that. The hinge theorem, like we said up here, needs for there to be two sides that are congruent to each other. And let's see if we can get that in example 4. Right now we have this is congruent to this, and if you can see real quick, there's this triangle, BAE, and then there's ADE, and they share AE. And when you share AE, that makes it AE is congruent to AE, and that's the reflex property. Okay, so let's look at number 3. Where do we need to go from here? So we've said that this is congruent, so we now have two sides, and then we have two sides again. Now I think this is where this is going to get a little tricky. We have two angles. We have the big angle EAB, which I'm marking right here in yellow. And then we have the smaller angle EAD, which I'm marking in purple. We can make some assumptions here. We can say that this big angle, BAE, is comprised of this little angle, EAD, and angle BAD. So combination of angle EAD plus BAD makes up this big yellow one. So let's go ahead and state that angle BAE is congruent to sum of BAD plus EAD. And that would be the angle addition postulate. Now that we have said that angle BAE is congruent to these other ones, we could say that the measure of angle BAE is greater than the measure of angle EAD. That's the definition of inequality. And we want to say that BAE is greater than EAD because those two angles are opposite the sides we want to work with, this side and this side. We want that here in our proof. So now that we're there, we can say ED is greater than EB, and the reason being hinge theorem. Let's move on. Let's look at the guided practice from example 4. So the guided practice, we're given that RQ is congruent to ST to prove that RS is greater than TQ. Okay, so we're given that RQ is greater than ST, and we're going to go on from there. We can say that QS is equal to or congruent to QS by reflexive property. Step 3, well, angle 1 is an exterior angle of QST, right? So if we state that by definition of an exterior angle, then we're going to get the greater sign involved because we know from the exterior angles theorem that the exterior angle is greater than the measure of either corresponding remote interior angles. Okay, let's write that out. We're going to say that angle 1 is an exterior. Step 4, that means that angle 1 is greater than angle 2 is exterior angle is greater than either if an angle is an exterior angle of a triangle, then its measure is greater than either corresponding remote interior angles. Okay, so now that we've stated that, we can state our proof. RS is greater than TQ. The hinge theorem, or sometimes referred to as the SAS inequality. The SAS inequality is the hinge theorem if you think about it. We're going back up here to this. It's a side, angle, side, side, angle, side. Converse hinge theorem means side, 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 and side. So for the converse hinge theorem, this is the SAS inequality, and this is the SSS inequality. Okay, so back to the guided practice part. All right, so that proves that in either one of these statements right here is true. I would accept either one. All right, let's move to example 5. This is on page 375. We're given T as the midpoint of ZX, ST is congruent to WT, SZ is greater than WX. And then we want to prove that the measure of XTR is greater than the measure of ZTY. And then we've got this like, I don't know, call it Imperial Darth Vader ship looking thing. So they wanted us to do a flow proof. So we start right here. We say T is the midpoint of ZX, it's given. Also, this is given, and this is given. And these all point to this part. Okay. Next thing is right here, ZT is congruent to TX, and that's the definition of a midpoint. So let's put that on here. This is congruent to this. And then we know ST is congruent to WT from given, so mark those up. And then we know that SZ, so SZ is greater than WX. Okay, so all this leads us to right here, the measure of angle STZ, so this angle right here, is greater than the measure of WTX. Okay, now those aren't the angles that they wanted us to find. XTR and ZTY. So XTR and ZTY. Now, if I were to draw some other angles in right here in yellow, look at the relationship of this pink and this yellow, and then this pink and this yellow. Those are vertical angles. So we'll state that right here, that the measure of STZ is congruent to the measure of XTR, yay, because we needed that one right here. And then we need WTX is congruent to ZTY, which is right here, yay, so we needed those. So we can say, based off of this converse of the hinge theorem, from here and here, we can say our proof that the measure of angle XTR is congruent to the measure. Whoa, it is not congruent. Try that again. It's greater than of ZTY. Okay, so let's move on to the guided practice 5. This is on page 375. We're given that NK is a median of triangle JMN, and JN is greater than NM. And they want us to prove that angle 1 is greater than the measure of angle 2. So we start out with our statements and reasons table. Number 1 is our given, a reason is our given as well. So let's go to statement number 2. So, and let's also mark on here what we know. We know that NK, right here, is the median. And the median goes from the point to the middle of the midpoint of the line opposite. So that means that JK is congruent to KM, and then we know that KN is congruent to KN by reflexive. So let's go ahead and state that. So we have KN is congruent to KN by reflexive property. For start over now. For number 3, K is the midpoint of JM. Know that K is the midpoint of JM by the definition of a median. Is to state that JK is congruent to KM, is the midpoint theorem. And then our last step is to do the proof, which is the measure of angle 1 is greater than the measure of angle 2. And again, we can use the converse hinge theorem or the SSS inequality.